When an unsuspecting ear hears terms such as regenerative farming or carbon sequestration, it's easy to think, oh, that sounds great. In this episode, we learn that carbon farming turns out to be yet another attempt to get us to applaud, and in many cases, even fund, the further pursuit of planetary destruction. You said carbon sequestering, and it's being presented like it's a great solution to some environmental problems, but I don't know what that word means.
The farmers have come up with this term carbon farming and regenerative ranching, where they try to say, well, we're storing more carbon in the soils with our cattle grazing or goat grazing or sheep grazing. And what they're actually doing is saying, well, we put manure back on the land, but what that really means for like a dairy like here, that means like gigantic amounts of liquefied slurry manure that's like someone's septic tank that they then spray or spread or dump onto these fields.
Hold on, say what? This calls for a moment of enlightenment, because when I learned about this for the first time, it was hard for me to believe. But here it is. When trying to imagine the amount of cattle waste produced in the national seashore, first you need to picture the poop that is falling directly from the cattle themselves to the ground or in the ponds where the cattle are grazing. But in addition, you then need to think about the shocking amount of waste being produced in their holding pens and at their designated feeding areas, which is then collected, liquefied, or dried, and then spread in addition to all the other cattle waste already in the seashore. The land and water here are saturated with shit, making the idea that what is needed here is more shit a complete joke. Especially once an ecologist explains to you how carbon sequestration works with the root system of a native plant compared to that of an annual invasive. Okay, sorry about that. Let's resume.
And it doesn't absorb down into the ground. It doesn't, if manure is the carbon, it doesn't sequester down into the ground because of the cattle grazing has trampled and denuded the land. There's too much bare soil, and so all that manure runs off into the ocean basically and pollutes the water.
You need plants to help that carbon get down.
Right.
Just leaving it on the surface, it doesn't take care of the process by itself.
Right. If we walk around on a cattle grazed area, you'll see the soil is compacted. If we walk around in the native coastal prairie here, the soil is spongy and deep, and the roots go down 3 to 6 feet. And so when a rain comes, the rainwater actually goes down into the spongy soil instead of running off.
But I see, this looks like there's plants everywhere.
But if you walk out into these cattle pastures that have been mowed, it's basically stuff like this. Little tiny, and here are the roots of it. These are the introduced, these might be brome grasses. That's the extent of the roots. These are little annual grasses that live a season, a spring, and then they die. The deep-rooted native perennial grasses are living for 100 years, 200 years, and their roots go down deep into the soil.
So we're dumping manure here and then saying that these roots are going to solve the problem of getting that down deep into the earth.
And that's not going to work. That's correct, but it won't work. These are just, the roots are not going to hold the soil together, and the soil compaction means manure will run off and not absorb.
Let's compare it to a native plant. What have you found?
So this is a native coastal prairie grass. It's Nootka reedgrass, and this thing might be 200, 500 years old, but I'm going to try to pull it up here, and you cannot. You need a bulldozer or a team of oxen. So this is what's sequestering carbon. Look at how tall the foliage is, and the roots probably go down 6 feet here.
6 feet?
6 feet. And then look at this. Oh my gosh, this is biological soil crust. These are little lichens coming up, and that's moss. So there's all sorts of mycorrhizal fungi that also go down. Here's moss. Look at these little fungi. This is really diverse. This cannot stand being trampled by 1,200-foot cattle hooves. Here's a lichen coming up from the soil. There's moss. This is actually great. You don't see this on the cattle pastures.
How would this react to, manure? I was raised to think of manure as a great thing. That's what you use if you want your plants to grow.
This is like a miniature rainforest. It takes in the fog and the rain. If you dumped manure on it, it would smother it, suffocate it, and a lot of it would just run off because you're trampling it with cows too. Cows, this is not in cattle pasture. I've never seen this in one of the cattle pastures here. It's like if you go to a cloud forest in the tropics, this is what this is like. Very delicate, but the mycorrhizal fibers, roots, go down into the soil and they interact with the roots of this native bunch grass.
Okay. You obviously know what you're talking about. For the people walking at home, walk us through mycorrhizal. What word did you just use?
Mycorrhizal, which means the fibers of mushrooms. Myco is like fungi. So we're talking about little, you can't see any, these might be little mushrooms. I think they're lichen, but so microscopic threads of mushroom roots is what we're talking about. But they also interact with lichens, blue-green algae, moss, and this is all together called biological soil crust.
Biological soil crust.
Right. It's like a crust on the soil surface, but the secret is the roots of all these delicate plants and lichens go down, and mushrooms go down deep into the soil too.
I'm glad you brought this up because I was just thinking to myself the other day, it's easy for us to recognize how a bird might use the brush, but it starts at a much smaller organismal level than that.
Right.
And are we looking at the beginning right here?
We're looking at the beginning. This is like an amazing, like a living soil. And this is where the carbon is really sequestered. There's scientific papers that show this. And dumping manure on top of this, that's not carbon farming. Carbon farming is leaving this alone and letting elk and deer softly tread by.
Okay. Elk and deer softly tread by. They're big, they have hooves. Why is that so different than a cow going by?
An elk probably weighs 400, maybe 600 pounds with kind of small cloven hooves. A dairy cow around here weighs what, 1,500 pounds? 1,200 minimum. And they're bred to just plant themselves and chew and trample, stand there, urinate, dump manure. Elk, being wild animals, their behavior is to wander. They like to wander in small herds and keep moving.
So they don't spend a lot of time in one spot.
Right. And especially if we could restore point raise without all the fences and barbed wire, we could really free up a large migratory movement of native Tule elk herds.
So the fences are actually preventing wild animals from behaving the way that they would normally behave.
Right. And it also concentrates these cattle herds right in one spot and really hammers this type of like living soil.
But nevertheless, a 400-pound animal coming through here, how does that not damage this?
Because they don't spend a lot of time right in the same area trampling, especially if you don't have fences. So, this biological soil crust has been here for thousands of years with Tule elk. There's reports of Tule elk herds and Point Reyes right up until 1872, and then they were displaced by the ranches. So these are co-evolved with Tule elk, and heavy cattle that are designed to stay in one pasture are not.
So even if we don't understand it, the bottom line is that these plants and those animals lived here together and they worked it out.
That's
somehow.
right. That's right. Yeah. And if we can restore that and then let them be a little bit more, then I think it would be a lot better picture than what we see today with cows. This is the sponginess. This is carbon farming, or this is carbon sequestration.
So small plants can be an effective part of carbon sequestration.
Small plants are the main part of carbon sequestration because the density of roots that goes down deep into the soil layers here, several feet, this is what stores carbon. And leaving this intact is what is going to really store carbon long term. And this is very difficult to restore. This is probably hundreds of years old. And if this were to be trampled and removed by cows, it would take, I mean, there are some research papers saying it would take 100 years to just start to replace this. This is a mossy cover here.
It's incorrect for me to point at a big tree and think of its root system and associate that with more carbon sequestration then.
It's not incorrect, but it's, people say plant a tree and that's what we're going to do to, save the world. But actually leaving grasslands and the mosses, the biological soil crusts, may do even more than a single woody root that goes down. I mean, this is like several square yards of soil that goes down quite deeply with the mycorrhizal filaments that are weaving through the soil. And this holds the soil intact from erosion and dust storms. I mean, a lot of cattle pastures are just full of dust storms when it's windy because there's a lot of loose soil that's disturbed. But look at this. This is a moist, no dust here.
What are you trying to do?
Trying to see how rooted this coyote brush is, and it's pretty rooted in there.
Wow.
Can't pull that out. Here's a iris, native iris. That, again, deep roots. You could maybe rip the leaves off, but you can't pull it out like an annual grass. All these plants here have deep roots. This is carbon sequestration, and it smells good too.